Okay, I'm continuing the one polynomial problem with everything. I got interrupted by the bell on the first one, and the first one is still valid, but I did catch my mistake. So what happened was, if you remember, it was this polynomial of degree 6 that we're looking at. We talked about the end behavior. We found the possible rational roots. My mistake was that I somehow missed a sign in here, and so I did this on another piece of paper. Let me see if I can talk you through that. There we go, that's a little better. Okay, so I have x squared minus 2 that I was dividing into this quartic polynomial, and when I did, I came down here and everything canceled, and I got a negative x squared minus 2x minus 2. So this might be a good idea. Pause the video right here and make sure you understand kind of how I did that long division. And then what that tells me is this quartic, degree 4, was the one they were calling g of x. So the g, no, I lied. No, that's right, so sorry. The quartic, degree 4, was g of x because the one with degree 6 is f of x. So then we wrote that now in terms of it was x minus 1 squared times this g of x. Well, now I have taken g of x and I divided it by x squared minus 2 and got this. So now g of x here can be written as x minus 2 times a negative x squared minus 2x minus 2. So what I did, I went ahead and factored out that negative. So this is g of x, which is now factored down to a quadratic and a quadratic. So if we think back, sorry, all the papers. If we think back to f of x, we now know 3 different quadratics that can multiply to get it. Well, actually 2 linear, and then now 2 quadratics. Okay, so then I went ahead and took this one right here, and I completed the square. So verifying that gave me a plus or minus root negative 1, which is I, and so I ended up getting roots of x equals negative 1 plus or minus I. And so now f of x, which was that polynomial of degree 6, had x minus 1 squared, and it had another quadratic, and then another quadratic. And this is how that factors down. Okay, so when we look back at our directions, so that was what I did without you. I can't find a green pen, but here it goes with the blue pen. So it says state all the solutions. Well, so when we look at f of x, we had these solutions here. We have a positive one, and then we had solutions from these 2 quadratics. So the solutions would be x equals a positive 1. Well, I don't need the plus sign. And then it was plus or minus root 2, which we had gotten from here. It traveled with the buddy, that root 2. And then the other one we got from completing the square was negative 1 plus or minus I. So I have 1 root that shows up twice, and then 2 more here and 2 more here. So I have a total of 5 different roots, but this one would have a multiplicity of 2. Okay, so now it says factor f of x completely over the rational numbers. And that means that all of my coefficients need to be rational. And so that was what we saw just a second ago. X minus 1 squared times x squared minus 2 times x squared plus 2x plus 2. So if I factor any farther, now notice this is linear, but these 2 are both quadratic, which means these 2 can both be factored farther. But if I try to, they are no longer rational. Okay, so this is as broken down as I can get it without leaving the world of rational numbers. Then it says factor completely over the real numbers. Well, if you remember, these answers right here came from this one. Those are real values right here, where these are complex, but these are real values, so I can break this down a little farther. And so I can say here that this is f of x is equal to negative x minus 1 squared. Now this one right here can now become x minus root 2 times x plus root 2. And this is x squared, that's a 2, plus 2x plus 2. Because if I try and break this one down any farther, I would get these zeros, which are not real. So everything here, all of my coefficients, these 2 are no longer rational, but they're still real. And the very last step says to factor it completely over the complex numbers. That means every piece needs to be linear because everything can be broken down to linear. So I have a negative and then an x minus 1 squared. This one, x minus root 2, x plus root 2. And now this one, if I forget for a second, I can come back to that other page. It was a negative 1 plus or minus I. So that becomes an x minus a negative is plus 1. And one of them is minus I. X plus 1 plus I. Sorry that. And this, has 1, 2, 3, 4, 5, 6 different linear factors that if I multiplied them all out would get me back here to this one right here. So hope that makes sense. Good luck to you. I would go practice. There's a whole lot thrown into that problem. Good luck.